Hi, it's Mr. Brewer back again to bring you another lesson on stoichiometry. Hey, before we get started, how about a little joke here? So, do you know why atoms should never be trusted? I don't know, Mr. Brewer, why shouldn't atoms ever be trusted? Well, I've heard it's because they make everything up. Boom, boom, Okay, in all seriousness tonight, folks, we've got a lesson here on stoichiometry again. Specifically, what we're going to be looking at tonight related to stoichiometry is a very specific goal. The goal for tonight's lesson would be to be able to identify what we call limiting reagents. We're going to look at it from a visual perspective first. What will eventually happen is it will become a mathematical idea for you. And once we construct the knowledge about what limiting reagent is, the mathematics will have a better chance of making some sense. So let's try to get started here. So again, from the beginning, our goal in this lesson, what we're trying to learn is how to identify limiting reagent from reactant quantities or amounts that are given that are available. We're assuming by this point in time that you understand what reactants are. They're the chemicals that we begin a chemical reaction with, the ones that rearrange to turn into something new. So let's start with something that you might be a little bit more familiar with. We have sort of an analogy here. Let me get rid of my face here so I can focus a little better for you on this lesson. There we go, that's better. If you look at a couple textbook definitions here, there's something called the limiting reagent. What that would be when we talk about chemicals would be the chemical that gets used up first, the one that gets completely turned into a new chemical that we would call a product. There's a term that's related to it called excess. That would be the chemical that there is extra of or leftover amount. So we have a little analogy here. The analogy takes a look at what we would call car bodies and tires. If we take a look at this, obviously it takes 4 tires to make a complete car. So if we compare the available amount of bodies to the available amount of tires, we can only produce a certain number of cars. So we think about the car bodies, or the chassis, as some people like to say, and the chassis and the tires combine in some very specific ratio. So let's take a look at these quantities that we have available. We've got a certain number of bodies available and a certain number of tires available. And it looks like this illustration is telling us we can make 8 cars from this. Let's take a look at why this is. So if we take away 1 car, what we know is going to happen is that takes away 4 tires with it, and that manufactures 1 complete car. And we can continue to manufacture. Another body takes 4 tires, makes a car. And we keep manufacturing. Bodies, tires, makes a car, body, tire, makes a car, body, tires, makes a car, body, 4 tires, makes a car, oops. And what we end up with is we see that we were able to make 8 cars, but we ran out of car bodies or chassis. So we call bodies the limiting reagent. It's what we ran out of. We call tires the excess reagent. It's the reactant that we had leftover quantity of. When we speak about actual chemicals, this is exactly what happens with chemicals. One of the chemicals will run out, preventing you from producing any new chemical called product. Here we are looking at the analogy of limiting and excess in a form that's a little bit more familiar to us. Let's begin to take a look at this from an actual chemical perspective. So here we have in this little window here, or this circle, the amount of particles available for a reaction. And what we want to focus on is we want to focus on the reactants, the 2 things over here to the left. Those reactants are very specific in terms of what we can identify them as. So in this case, there's a reactant of CH4, methane. It looks to me like this would be our CH4 particles. It's made of 5 total atoms. So our reactants are in the circle here. Our O2 particles would be these 2 blue particles joined together. And we see there's a certain quantity of these available. Well, what we look for is we look for the coefficients. The coefficients reveal what the quantity is as these react. it looks like since there's no coefficient in front of CH4 and a 2 in front of oxygen, they're going to react in a 1:2 ratio. And when they do that, they will produce products. What they'll do is they'll produce 2 molecules of water and 1 molecule of carbon dioxide. So let's begin using up these reactants just like we did with car bodies and tires. So we're going to use up 1 CH4 and 2 oxygen. That'll manufacture some product. Let's continue reacting. 1 methane or CH4 with 2 oxygen, and that'll make more product. And we continue reacting. That'll make more product. We're using them up in the 1:2 ratio here, and it completes, or it continues to manufacture product as we do this. We take away 1 CH4, it takes 2 O2s with it. That makes some product. We take away 1 CH4, it takes 2 O2s with it. And we notice all of a sudden that we have run out of O2. O2 is no longer present as reactant. If therefore used up the O2, we would call O2 our limiting reactant because the O2 has been completely used up. So we label O2 down here on the bottom as our limiting reactant. That means our products will stop forming because we ran out of oxygen, which basically means we have excess methane or CH4. There's quantity of particles left over as reactants as the CH4 form. This is the idea in a visual perspective. Let's take a look at a different chemical reaction here. We're only going to consider looking at the reactants because it's not really necessary to think about product formation just yet. We'll do that with mathematics in another lesson. Actually, another part of this lesson followed with another short video. So we're looking at our reactants. We have aluminum, Al, and chlorine, Cl2. Well, it looks to me like Al would be these single atoms here, the large blue atoms, and Cl2 would be these molecules made of 2 particles joined together. It looks to me like the ratio is 2:3 by looking at the coefficients. So let's begin to use these up in the 2:3 ratio. So we're going to use them up in a 2:3 ratio. We're going to take away 2 aluminum. So we'll take away 1, 2 aluminum, and that will take 1, 2, 3 chlorine with it. We'll take away 1, 2 aluminum, take away 1, 2, 3 chlorine with it, take away 2 aluminum, take 1, 2, 3 chlorine with it. What we notice is we've run out of aluminum. Since we've run out of aluminum, we now call aluminum our limiting reagent, and we can mark aluminum as what we would call limiting. Al is our limiting because we've run out of it. And chlorine would be our excess because we have extra quantity of chlorine molecules left over to continue the reaction. So limiting and excess from the perspective of thinking about particles is a pretty simple thing to do. Unfortunately, you can't really see particles in the physical world. So this analogy kind of breaks down when we actually have to look at chemical quantities, things that are measurable. But again, we're going to label our aluminum as our limiting, which means our Cl2 or our chlorine becomes our excess. Again, limiting and excess have to be on the reactant side, never over here on the right side called the products. Let's clear this and start again. Okay, so now we have 2 different particles available. It looks to me like we have barium oxide, barium and oxygen, and we have water. So our 2 reactants are BaO and H2O. So what we're going to do is we're going to cross them out in the very specific ratio that it's identified as. So it looks like there's a 1-for-1 ratio here. So we'll use them up in a 1-for-1 ratio, 1-for-1, 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 and we continue using up in this 1-for-1 ratio until we've run out of one of these reactants. And it looks to me, oh, we still have a little bit available yet, 1 for 1. And it looks to me like we have used up all of our H2O, our 3 atom molecules here. And it looks like we have some barium oxide, BaO, left over. Therefore, we can label our limiting and our excess. Our limiting is what we've run out of. In this case, we've run out of water. So we're going to label water as our limiting. Again, we have to focus on the reactant side, not the product side. So water becomes our limiting reagent, which means barium oxide, or BaO, because we have extra quantity of it, these particles, the black and red, we would call that our excess. Let's clear our drawing here, and let's pause so maybe you can think about the actual ratios in the next example that we're about to present here. So here's an example. We have iron, Fe, and oxygen, O2. It would be a good idea for you to pause the video at this moment to see if you can determine which of these reactants, the Fe or the O2, is limiting and which of these is excess. Go ahead and pause and see if you can figure that out. Well, let's start crossing them out in the correct ratio. What we're going to see is we're going to see 1, 2, 3, 4 iron because the coefficient is 4. We'll take away 3 oxygen because the coefficient for oxygen is 3. 1, 2, 3. 4 iron. 1, 2, 3, 4. Takes away 3 oxygen. 1, 2, 3. 4 iron. 1, 2, 3, 4. We don't have enough oxygen to continue onward. Oh, we do. We still have 3. 1, 2, 3. We've now run out of oxygen. So you've guessed it. Oxygen becomes our limiting because we ran out of that. We have extra quantity of iron left over. So why don't we go ahead and label our oxygen as our limiting. Again, it has to be a reactant. The limiting reagent we would call oxygen in this case. And the excess, what we have extra quantity of, would be our iron or our Fe in this case. I think we have one more example that we can work with to wrap up this lesson for you. So here we have a quantity of reactants available. Looks like the ratio that they react in is a 2:5 ratio. Go ahead and pause the video and see if you can come up with quantities that will allow you to determine what is limiting and what is excess. Okay, let's begin to use them up. It looks like our C2H2 is actually a molecule called acetylene. So that's going to be our 4 atom molecule. So we're going to take away 2 acetylene. What that will do is that'll take 1, 2, 3, 4, 5 oxygen molecules with it. We'll continue reacting because there's plenty of particles. Oh, wow, look at this. We don't have 5 oxygen available anymore. We got plenty of acetylene, C2H2, but we don't have 5 oxygen molecules. So it looks to me like we don't have enough oxygen to continue, but we've got plenty of acetylene, or C2H2, to continue. What this tells me is that oxygen is limiting. We don't have the correct quantity of oxygen to continue. We would need 5 molecules of oxygen, and it looks like there are only 2 molecules of oxygen left to continue this reaction. So if we label our oxygen as limiting, that means our acetylene, or our C2H2, becomes our excess. So this concludes our lesson today on understanding, at least from a visual perspective, what limiting and excess reagents are. Until the next time, I'll see you soon. I hope this video was useful in you understanding the concepts.